Lesson 3.2 is adding, subtracting, and multiplying polynomials. All review. All stuff you've done, all stuff you know how to do. We just need to go through and review. Okay, so adding and subtracting polynomials. You guys know, to add and subtract polynomials, we're going to be looking for like terms. Okay, remember like terms, their pieces are exactly alike. So their variables are alike, the exponents on the variables are alike. Those variable pieces are just identical. Okay, so let's look at A. 6x cubed plus 4x plus x squared minus 7. Notice here in the middle there is a plus. That's your big clue as to what we're doing here, right? 2x cubed minus ax squared plus 3. So, what do you see?
We got the degrees are the same. So we've got to add them together.
Okay, what are we adding together?
6x cubed plus 2x cubed.
Okay. 6x cubed plus 2x cubed is 8x cubed.
X squared negative 8x.
Ah. There's a plus x squared and a minus 8x squared.
So there's 2x squared. Be minus 7. Minus 7.
Okay, so 1x squared plus negative 8x squared is going to be minus 7x squared. What else you got for me?
Plus 4x.
Okay, 4x is just by itself, no other like term, so carry it to your answer, plus 4x. And
Negative 7 and 3.
there's a minus 7 and a plus 3. Minus 7 plus 3 is going to be minus 4. Okay, now you guys took it upon yourself. As we went, you put it in standard form, which it may be required, it may not be required, but it's always a good thing to do. Okay, is to go for that standard form. Okay, B. What, you want them all that easy? Okay, well, what changes on B? Okay, there's two variables, so we have to be extra careful of our like terms, and it's subtraction, yes? Okay, so beware, when we go to do this problem, you're subtracting all of these terms from the second parentheses, yes? Okay, what do you see?
The 3x squared y squared, the 2x squared y squared.
Okay.
Add those together. Subtract them together.
3x squared, officially minus, 3x squared y squared minus 2x squared y squared is going to be
X squared y squared.
1x squared y squared, or yes, like Patrick said, x squared y squared. Forget the 1. Now what?
2x y squared and 3x y squared.
Okay.
Subtract those. And then just have x y squared.
2xy squared and 3xy squared. They both have the xy squared. It is subtraction. 2 minus 3 is going to make it, or I'm just going to write minus xy squared. It is equivalent to plus negative x squared, xy squared. Savas isn't going to want to see a plus negative though. And
6 minus negative 2x squared.
6x squared minus negative 2x squared is?
8x squared. X squared.
Oh.
6 minus negative 2?
Plus 8.
Plus 8x squared. Okay. In terms of standard form, that one's a tough one. You put in standard form when you start throwing two variables in. The smart move is what you guys did. You went with the form that they provided. Okay.
I can get behind this.
You like this? Okay. See, let's keep us moving. Maybe we can get some crazy stuff called work time. We just gotta keep moving. Okay. What do you know?
4 is by itself. 4 is squared. No,
Yeah, 4, 8. Quad.
Quad.
4A quad.
4a to the fourth is what I usually say. No other a's to the fourth, so it's going to stay 4a to the fourth. What else? Okay. Minus 6a cubed. Notice, what are we doing this time? This is an addition problem. So minus 6 plus 5 is going to be minus 1a cubed. Next.
Minus 3a squared plus 7a squared.
Minus 3a squared plus 7a squared
Plus 4.
plus 4a squared.
8 by itself. No.
No, a plus 2a.
We have a 1a and a 2a. 1a plus 2a is 3a. And lastly,
1 plus -2.
1 plus negative 2 is negative 1. Okay. Probably the challenging part on Savas is you can't make any tiny mistakes, right? It's easy stuff to do, but you just can't make the tiny mistakes, so it'll get you in trouble.
Hope it's multiple choice.
Yeah, I don't think it's multiple choice.
That'd be
So, okay, one more in our adding subtracting section. I'm not going to bother to read it out loud. You got it there in front of you. Lots of A's and B's, yes? Okay. And we are subtracting. Always look at what's in between those parentheses. What do you see first?
A squared, b squared.
So a squared, b squared terms.
2 minus 3a squared, b squared.
2a squared, b squared minus 3a squared, b squared is going to be negative a squared, b squared, or negative 1a squared, b squared.
3ab squared minus 7.
Which one's what you put first? Since it's the a squared.
It's a tough call. I mean, a squared, I say, what did I do? I went with and did the a b squared terms next on my notes. I think I probably did that because that's what the order of the first parenthesis. The key is, did you guys catch my next two terms flip-flop, don't they? Okay, so 3ab squared goes with 7ab squared. Okay. In terms of whether you do those or the other terms first, I don't think Savas is going to care in that situation. Okay. So
Negative 4ab squared.
we are subtracting. So 3 minus 7 is going to be minus 4ab squared. Huh?
Is that half that?
And lastly, minus 5a squared b minus negative 9a squared b
plus 4.
is going to be plus 4a squared b because it is negative 5 minus negative 9. And we seem to learn from our previous mistake on that one. Okay, if you have those last two terms switched, totally get it. Again, I don't think Savas is going to throw a big fit there. Okay, all these problems were addition and subtraction. We knew they were addition and subtraction because they had add or subtract inside those parentheses, right? Okay. Moving on. Our other topic today is multiplying. Okay.
Just keep this.
In order to multiply, okay, think distributive property. You can think FOIL, except a lot of what we're doing today is going to be bigger, badder versions of FOIL. Okay, it's not going to be just binomial times binomial, but it's the same idea. Okay, so we use the distributive property, group like terms, and combine. Okay, same deal about like terms. So Shall we start multiplying?
I guess.
Okay. Now, how do I know these problems are multiplying instead of adding or subtracting?
There's no add or subtract.
There's nothing in between the parentheses, right? Common mistake I see that happens on homework, quizzes, tests. This is multiplying because parentheses next to parentheses, okay? So, what do you want to do first?
2m.
2m, multiply it by,
Make it 3.
let's start with 2m times 3m squared.
Be 6 and trace.
6 in trace.
6m to the third.
There we go.
Coefficients out front, you're multiplying. Exponents we will be adding when we multiply, right? I would just take the 2m and keep going. 2m times minus 4m.
Negative 8 squared.
Minus 8m squared. 2m times 2
4.
plus 4m. Okay, continuing along. Repeat the process with the 5, yes?
Plus 15.
5 times 3, 15m squared.
Plus minus 20.
5 times minus 4m is going to be minus 20m. And
10.
5 times 2 plus 10. Do you get to stop there?
Yeah. Simplify.
There's probably some like terms you can add. Not guaranteed, but most likely. Let's see. 6m cubed stays 6m cubed. M squared
7 plus 7.
minus 8m squared plus 15m squared is plus 7m squared. 4m goes with 20m. 4m minus 20m is minus 16m, and plus 10 hangs out at the end. Okay.
That's it.
Fair enough?
It's going to get worse, ain't it?
You see D?
I don't think B gets any worse.
D does.
Okay, let's try B. 6n squared minus 7 times n squared plus n plus 3. And notice, I'm not wasting a lot of time with binomial times binomial, am I? We FOIL all the time. This is the bigger stuff that we don't do all the time. So that's more of my focus. So, okay. 6n squared times n squared.
6 and 4. Quad.
6n to the fourth.
Keep the quadrant.
6n squared times n.
6 and trace.
6n to the third. 6n squared times 3.
18.
Squared.
18n squared. And
7.
take that minus 7. Minus 7 times n squared.
Minus 7 and squared.
Minus 7n squared. Minus 7 times n.
Minus 7.
Minus 7n. Minus 7 times 3.
Minus 21.
Minus 21. Okay, never stop. Always check and see what you can put together. I do see at least one set of terms that can be added together, correct?
Yep.
So we end up with 6n to the fourth
So 11
plus 6n to the third.
n squared.
My n squareds can go together, so 18 minus 7 is 11n squared. Minus 7n minus 21. Okay. Thoughts on C? It's 7m squared minus 3, quantity squared.
Yeah, squared.
What are you guys saying?
Square root. The whole thing.
I'm not going to square root.
Square.
Just -3 times -3, 7 squared. That's a good idea.
You're going to be leaving some information out. Yeah, okay. So when you see this quantity squared, my recommendation is that you write it out. Because when we see the squared, the common mistake is to just take 7m squared and square it, take the -3 and square it, and say those two values are my answer. But you're going to be missing the middle term, okay? So write the binomials out side by side, and then it's another distribute, or this is where we could actually think FOIL, right? Okay, I did throw one in like that. So first, 7m squared times 7m squared. 49, m to the fourth. Add those exponents. 7m squared times -3. -21m squared. That was outsides. Insides, -3 times 7m squared. -21m squared. -3 times -3. Plus 9. Okay. Any cleanup?
Yes.
Yep. So 49m to the fourth stays. -21m squared, -21m squared.
That's 42.
About -42m squared. And plus 9. Notice my middle terms did not cancel out, did they? In case you made that mistake. Okay, they're the same sign, so we add them and kept the sign. Okay. D, the one Ruby's awaiting. Thoughts?
Perfect.
mn cubed. And then plus 1 minus 2 plus 4. Takes the first term and distribute the second.
Okay. Yeah. My recommendation is we're going to start by looking at these two right here.
So you
Okay.
split them up.
So we're going to hold on to the mn plus 4. We're going to multiply these two, get that answer all nice, and then multiply again.
Doesn't
Okay.
matter.
Does it matter?
If I do like mn minus 2, mn plus 4.
It does not matter which two parentheses you pick first and which one you save for last. But they all have to be done. I don't know, maybe there is some fancy way to multiply all three of them at once, but general rule of thumb, pick two, and then we'll multiply the other one in. So, what about mn times mn?
mn squared.
You can only say mn squared if you're going to write it
M squared.
mn parentheses squared.
N squared. Look at that.
So really, ideally, what we should be writing is m squared n squared. Okay? Because you're adding the exponents on the m and you're adding the exponents on the n. Okay? mn times minus 2.
Minus m2.
I'll go get it.
Minus 2mn. Okay? Insides. 1 times mn is
N plus mn.
plus 1 mn. And then 1 times minus 2,
Let's do it.
minus 2. Now, I'm going to put that in parentheses because I know how forgetful we all can be, myself included. I'm going to go ahead and carry down this mn plus 4. Okay? Now, my recommendation before you do this next set of multiplication, is there a little cleanup that can happen?
Yeah.
It's not much, but every little bit helps. If you clean it up ahead of time, it's going to be easy. It's going to save us a step later. So, m squared, n squared. What is minus 2mn plus 1mn?
Minus n.
Minus 1mn, or minus mn? Minus 2. And then, I'm going to carry down the mn plus 4 again. And now I'm ready to multiply one more time. Okay. Options. How do you want to multiply?
Go for it.
I just don't want to do it, to be honest.
Okay. So,
Just have to multiply 2 instead of multiplying.
so any way you do it, we're going to end up with 6 terms. One option is, okay, m squared n squared times both of those pieces, minus mn times both of those pieces, minus 2 times both of those pieces. Or, Paula was just asking about flipping it. I tend to take the mn and multiply it by each of the pieces. And then take the 4 and multiply it by each of the pieces. I don't necessarily have to rewrite it to do that, and it doesn't matter. So if I look at mn times m squared n squared.
M cubed, N cubed.
Good. Add those exponents, m cubed, n cubed. Mn times minus mn.
Minus M squared.
Minus m squared n squared. We're adding the exponents. Good, we've got that habit going. Minus 2 times mn.
Minus 2.
Minus 2mn. Okay, we got the hard part out of the way. The other piece is just distributing the 4, yes? So 4 times m squared n squared
Plus 4 M squared.
plus 4 m squared n squared. 4 times minus mn
Minus 4.
minus 4mn. And 4 times minus 2
Minus
minus 8. Okay, almost there, almost there. Clean up.
M cubed,
M cubed, n cubed carries down.
and then 3 M squared,
Okay,
plus
I've got minus 1 m squared plus 4 m squared n squared. Minus 1 plus 4 plus 3 m squared n squared.
minus 6 MN.
Minus 2mn minus 4mn is minus 6mn. And don't forget
Minus
the minus 8.
That's a mouthful.
It is much easier to write than to say. Okay, we've got the basics, guys. Okay, we've got one last word problem on the back I want to look at. That, of course, is going to involve some variation of adding, subtracting, multiplying polynomials. Okay, so a box is to be made out of a rectangular piece of cardboard that is 20 inches long and 14 inches wide. Squares, X inches on a side, are cut out of the corners and the sides are bent upwards. Write an expression for the volume of the box. Okay? So, I'm going to draw us a picture. Nope.
Yep.
Nancy says no.
Oh, must be that. Good bond.
Okay. Nope, this is a rectangular piece of cardboard. I got my purple rectangular piece of cardboard. A box is going to be made. I haven't made my box yet.
We just did make.
Okay, now, this rectangular piece of cardboard is 20 inches long and 14 inches wide. Okay. Squares, X inches on a side, are cut out of the corners, and then the sides are bent upwards. So, I'm going to take a little corner here, and I'm going to cut out a square that is X by X. And I'm going to do that at all 4 corners. Each of the 4 corners, I'm cutting out a square that is X inches by X inches. Okay? Now, we're asked to find we're going to cut those squares out. And then once those squares are cut out, You fold up the remaining edges and you make a box. We need the volume of the box. So let's talk about volume formula. Okay? Volume of a box, length times width times height. Now, we're not doing volume of a rectangle. Not that you can do volume of a flat object anyways. Okay? Volume of the box. So what I need to know here is what's going to be the length of this box.
20 inches.
Yeah.
The length of the rectangle is 20 inches.
16 inches. That's my guess. 16.
Whatever x
They
is
cut
square.
off the.
Well, not square. X 2.
I say we just build the box. Don't worry about it.
Yep. I said we just create a little box.
So I'm going to take,
Not that.
Sounds like a first of box.
I'm going to take my rectangle. Here's my rectangular piece of paper. Ooh, that's not very equal, but I'm cutting out my 4 corners. We're going to pretend all 4 corners are the same. They're not going to be.
Oh, I get what we're doing.
Okay?
Fold that bad boy.
So this was a rectangular piece of paper. I cut out my 4 pieces, and then what's happening?
Fold the box.
These flaps are going to fold up. This is going to be a very crude looking box, but we're going to get the idea, right? Ooh, very rough. Okay, so there's my box.
I get that A for effort.
I need a length of this box. The length of the paper was supposedly 20 inches,
So we gotta find the X
So it's
value.
like 10.
So yeah.
but we don't know the X value, so we're just going to use X.
15.
We're gonna guess. So it's 20 minus 6 squared.
It's going to, so
Would be the
this length right here, I want to know this length from there to there, basically.
one minus
It was 20.
14.
And what are we taking off? We don't know an exact number. We're taking off
X squared.
X and X. Not X squared,
X2X.
2X. Okay? So your length is going to be 20 minus 2X. What about my width?
14 minus 2X.
Are you seeing it? The width of the rectangle was 14, but if I take off the 2 x's, 14 minus 2x, that is my width.
So you I'm in parentheses.
Oh, what about the height?
So my length, oh, we haven't talked about that yet, have we? Okay. The length is 20 minus 2x. The width is 14 minus 2x. And then we need a height. Okay,
But
I folded up these flaps. What's the height of this box?
pretty tall.
X.
X? Because these flaps are how wide? These flaps, I cut off the X, the squares that are X by X. You fold that up, that's X, yes?
Yeah.
So, the height of the box is X. So there you've got your length, your width, and your height. Now, the name of the game in this lesson is multiplying, adding, subtracting, multiplying. So do you get to leave your answer like this?
No.
No. We're going to keep going. My recommendation, we do the foiling first, and it'll be easy at the end to multiply your x in. That's my recommendation. Okay? So I suggest we foil these.
280.
20 times 14, 280. 20 times minus 2x, minus 40x. Minus 2x times 14, minus 28x. Minus 2x times minus 2x. plus 4x squared. I'm going to put that all in parentheses because I need to remember to also, when I get done, multiply it all by the height of x. I would do a little bit of cleanup.
60.
280 stays 280. Minus 40x minus 28x minus 68x plus 4x squared times x. Final answer.
280x minus 68x squared plus 4x.
Okay, 280x minus 68x squared plus 4x cubed. That is taking the x and distributing it. That means you're just adding one to each exponent, aren't you?
You don't have one of these on your sonnets, right?
You do have one of these on your Savas. Now,
How is that?
I just looked at something in my notes
That's
and realized down below, I also found the area.
Oh, well.
Why would you do that?
I'm guessing I did this because why? Savas threw it in. I'm guessing that's why I did that. Because I just looked down and realized I think I added it in after the fact. Now.
We'll figure it out tomorrow.
Yeah.
Okay,
We'll cross that bridge when we get there.
or we can do it real quick.
No.
Yeah,
Well, we didn't have an option.
pretty much. Sorry,
I get it.
I forgot. I should have written it in after the fact since I forgot. But now, if I remember how Savas asked the question, it would be better. But my guess is that they also ask, it would be called surface area, right? Because when we talk area, it's of a flat object, right? Of a two-dimensional object. So in this case, I can't find area of a box. I find surface area. So the area of each of the sides. Okay? So with that in mind, we're going to come down here and we're going to talk about area. You guys have plenty of room down below. I have mine down below on my paper. So, thoughts on area? Okay. Area of a rectangle is length times width. Yes? What do I basically have here? 5 rectangles? Yes? So it's finding the area of each of those rectangles.
So would you just
So we only really got to find the area.
True. Are there some overlapping rectangles there?
Well, on that.
Okay. So let's start with the base. Right here. This rectangle that is the base of my box. What would be the area of this rectangle here?
280?
Keeping in mind, we're looking at that right there as the base, yes? Okay. What's that base going to be? It's not 14 times 20 because that's the whole piece, the whole rectangle. What was the length of the base? 20 minus 2x. What's the width of the base? 14 minus 2x. So this base is going to be the 20 minus 2x times 14 minus 2x. That's the base right here, yes? Plus, because we're adding all these areas up, right? Surface area is the area of this side plus this side plus this side plus this side. Okay? Now, let's go for the long sides. What is the area of just this side here? So now I'm looking at this flap here, yes? What's the area of that piece? 20 minus 2x times x. How many of these rectangles are there? 2. Can we go ahead and also multiply that by 2?
Yeah.
So I'm going to put this as 2 times x times 20 minus 2x. You with me? And then, what else do I have? Okay, these end flaps, the smaller sides, right there. 14 minus 2x times the height of x. And there's how many of them? 2 of them. So that's going to be plus 2 times x times 14 minus 2x. You could leave it like this. Then Savas is going to say, well, this is equivalent to the correct answer. It is not your final answer. Multiply all the pieces, right? Then like terms. So, okay, let's get this done. First 2 pieces we're going to have to foil. Technically, didn't we already foil these once? Yeah. Oops. 20 times 14, 280. 20 times minus 2x, minus 40x. Minus 2x times 14,
Minus 28x.
minus 28x. Minus 2x times minus 2x, plus 4x squared. Your other pieces are each a distributive property. 2x times 20, 40x. 2x times minus 2x, minus 4x squared. And 2x times 14, plus 28x. 2x times minus 2x, minus 4x squared. Okay. Like terms. I see a 280. Minus 40x minus 28x is, oh, well, okay, I was going to say minus 68x, but actually, this is, be logical, minus 40x plus 40x minus 28x plus 28x.
They all cancel, so x is gone.
X's just all canceled, didn't they?
Yeah, they-
Okay. Plus 4x squared minus 4x squared
cancel it.
minus 4x squared. Minus 4x squared. And that is your surface area. Okay? So you're at least prepared now if they ask for surface area.
Can I take a picture